Alright, what we're going to do today is go ahead and solve some systems of linear equations using specifically some word problems. But instead of using the calculator, not everybody has access to one, so we're going to use Desmos today. So here are the two examples that I would have done used a calculator on in the fourth section, 3.4. And we are going to just do those same exact problems, but instead of the graphing calculator, we will use Desmos. Okay, so this is number 3 on 3.4 notes, page 4. The revenue for the school play is given by R is equal to negative 50t squared plus 300t, where t is the ticket price in dollars. The cost to produce the play is given by C is equal to 600 minus 50t. Determine the ticket price that will allow script and cue to break even. Okay, break even means that they want to know when revenue is equal to cost. Okay, so in these particular problems, I want to know when that revenue is equal to that cost. So essentially what we can do is we can write two functions into our Desmos, and honestly, all we're going to do is see where they cross. Okay, so if my revenue here, R, is equal to negative 50t squared plus 300t. Now this red graph here is going to be my function of my revenue. As the ticket prices go up, will continue to go up until you hit a threshold where it's too expensive, where people don't want to go, and then it's going to start trickling back down. Okay, and then we have the cost, which is $600 minus $50 for each ticket we are able to sell. So this is going to be C is equal to 600 minus 50t. Okay, and I just want to know where these two lines cross. Now the problem is, as you can see here, we really don't have a ton of space to see what's going on. So what we're going to do is we're going to use some just visual hints that are going to help us. For example, my x values seem to be between 0 and 6, so let's go ahead and fix that. We're going to go ahead and say that this is 0 and this is going to be 6. Okay, and that gives us our x values to go between, but the y values, that could be tough. So what we're going to do is we're going to use this q here, knowing that this graph here has a y-intercept of 600, and then it decreases 50 units for each one. So that means that the bottom of this thing here is going to be, 600, maybe to 400 or 300. So let's just go ahead and just take a guess. Let's fix the y-axis between 300 and then also 600. Okay, and then now what we can do is we can see. So all I did, folks, is I just kind of used some visual cues that they had given me, and then some information I know about the graph, specifically the linear graph here. Okay, I want to know what ticket price that will allow them to break even. Okay, so allow me to have the, like I'm not making a profit, I'm just going to go ahead and I'm going to make I'm going to break even. No money made, no money lost. So as I see here, you can see if I start highlighting one line here, as I can trace here, but then it will kind of create these black points here. And those are those gray points. As I click those gray points, those are my intersecting points. So it intersects at two different spots for us. It will go ahead and break even when x is 4 and when x is 3. So what's the answer to this question? There's actually two. When the ticket price is $3, the amount of money you make and the amount you're going to have to spend is going to be the exact same amount. Okay, so that means they are going to break even when the ticket price is $3 and when the ticket price is $4. Okay, let's go ahead and pull up that other question here, and let's go ahead and answer it quick. As a matter of fact, though, I think that this should be a problem that you should try on your own and then check it with me. Okay, so go ahead, pause the video, and try this one on your own using Desmos. So I'm assuming that you've already tried this one. You're here to see how you did. Okay, a punter kicks a football, its height h in meters. T seconds after the ball is kicked is represented by the equation negative 4.9 t plus 18.24 t plus 0.8. The height of the ball, the height of the approaching blocker is modeled by negative 1.43 t plus 4.26. And it wants to know, can the blocker knock the punt down? If so, what time does this happen at? Okay, so we're going to go ahead and erase these two equations, and then what we're going to do is we are going to write in our equation. So my first one is h is equal to negative 4.9 t squared plus 18.24 t plus 0.8. And then the next one is just going to be h is equal to negative 1.43 t plus 4.26. Okay, so let's go ahead and get our graph back down to its like original. These numbers are so much smaller, so let's go ahead and just get from 0 to 10, and then from 0 to 10 again. Okay, we can already start to see the graph. Okay. Okay, perfect. So just by chance, I've managed to see this. So let's go ahead and look at this graph here. So it looks like it crosses at 2 points. Okay, it crosses at about 0.184 seconds, but then it crosses later down here in 3.83 seconds. Okay, and so we want to know if this green path is the height of the ball, okay, and this purple line is the height here. You know, one of these points doesn't make a whole lot of sense. Now, mathematically, is this a solution to where these two parts are equal to each other, where the height of the ball and the height of the person's hands are the same? Yes, but does it make sense in the context of the problem? No, because this would be having a negative amount of feet below ground. So that would kind of represent them being below ground. And unless there's some very extreme circumstances going on, that is not going to happen. So really we want to only look at things above the y-axis. So I'm looking at this point here, okay, at 0.184. So after about 2 seconds, that ball appears to be about 4 feet off the ground. And that's where the player's hands are. So we imagine this as the ball going up and then this guy's hands going here. Where they're meeting here after about 2 seconds and at about 4 feet off the ground. So can the blocker knock the punt down? In this situation, yes, they can, because their height are going to be at the same spot at the same time. If so, at what time does this happen? This happens at 0.184 seconds, give or take. So right off the bat, guy gets a good jump and is managing to block it down. Okay, that's it for the Desmos version of this, because everything else appears to be able to be done by hand. So I will see you all next time for the next lesson.